Today we're going to be talking about force. A force is a push or pull on an object. Some examples of force are friction and gravity. And please note that even though we know gravity is pulling on us, we can't see it. So not all forces can be seen. A force is usually described by its strength. And we can represent this in a diagram called a vector, which I will show you here in a few minutes. The strength of a force is measured in a unit called newtons, and we represent that with a capital N. So we'll talk a little bit about how you measure newtons and how much a newton is. So how do forces affect motion? Because that is really the main thing here, is when a force is put on an object, how does that affect the motion of the object? When we're talking about all of the forces acting on an object, that is called net force. So that's the combination. And if we're looking for all forces acting on an object, a lot of times we have to add up all the forces, and that is called our net force. And we can, again, show this with a diagram called a vector. If the net force on an object is 0, then that means the object is not moving. So if you think about an object sitting on a table, it is not moving, but if you were to push it, then that force would not be a net of 0. So that means overall, it is not a 0 force. So that means the object will end up moving. But if it is a 0 force, which means the force acting down on an object is equal to the force acting up on an object, then the object is not going to move. So the net force is the combination of all the forces acting on an object. If the net force is 0, the object is not moving. If the net force is anything other than 0, then the object will be in motion. And you cannot have a negative force. So all force numbers will be represented with a positive number. So here are just some examples. So in this top example here, you can see we've got two dogs and they're pushing this box of treats in the same direction. So you can see that this big dog is pushing with 16 newtons of force and the bottom dog is pushing with 10 newtons of force. So all we do to get our net force is we would add those forces together. So what would we would add 16 plus 10. So the way we would write this is 26 newtons. And then we have to include the direction. And since they're both going in the same direction, we added, and then our arrow would be going that way. So that would be the net force on that object, the box of treats. In this other example here, now the dogs are pushing in opposite directions. So we take the big force, 20 newtons, and we subtract the little force from it. Okay, so 20 minus 10 is 10 newtons. And which direction will the box end up moving? Well, since this dog is pushing with 20 newtons of force, and this dog is pushing with 10 newtons, the net direction that this box is going to move is this way. So we would add our arrow here. So that would be our answer to our problem. Down here, we've got two little dogs, and they're both pushing against each other with 10 newtons of force. So if they're both pushing with the same amount of force, that box is not going to move because they're pushing in the same direction with 10 newtons of force. So we would say 0 newtons because this box would not move. So we've used some different words here to describe forces. A balanced force. So that means that is when we have a net force of 0 when the object does not move. So that would be just like this example. This is balanced, 10 going this direction, 10 going the opposite direction, so it's balanced. And this box of dog treats would not move. So we call that a balanced force. No change of motion, object does not move. An unbalanced force means the object is going to move. The net force is not 0, and we will have a change of motion. So that is like these two examples up here. We have 26 newtons of force going in one direction. This box is going to move. We have 10 newtons of net force going in this direction. This box will move. So that is considered an unbalanced force. All right, both of these together are both measured in newtons, so we would use that capital N. Both of them are considered a push or pull, and both of them have direction. So we use this even when we cannot see the forces. So not all forces can be seen. For example, magnetism can't be seen, gravity can't be seen, and so we'll talk more about these later, about unseen forces. So to finish up forces here, we are going to talk about and look at some examples of vectors. A vector is a diagram that we can use to represent forces. It's very similar to the dog example. So a lot of times we use it like this. So this block is just representing an object, and the arrows are representing forces. So in this example, we've got 10 newtons going this direction, 5 newtons going this direction. It's kind of like an example of tug of war. So the way we would answer this, since they're going in opposite directions, we're going to subtract. So our answer here, 10 minus 5 is 5 newtons. And since it is more going up, then our arrow is going to point up. Here we've got 10 and 10 going in the same direction. So our net force would be 20 newtons going up. Down here, 7 and 7 going in opposite directions. So is this object going to move? No, this object is not going to move. So we have 0 newtons. And so we would consider this object balanced. And then in this object, same thing. We're going opposite directions, so we'd have a 0 net force. This last one is interesting. Clearly, we would probably go in some direction kind of like that because we're going more up and more this way. But the way we write this is we're going to write 10 newtons up because I've got 10 newtons of net force up and 2 newtons to the right. So next in your module, you have a couple practice problems on vectors. Thanks for watching.